Hello, we are doing problem number 7 today. Problem number 7 states it wants basically for us to write our own ATOI. It takes a string as an argument and converts it to integer. So, and they want a string to integer um, function. So we're gonna write our own ATOI function. I am actually not sure how to pronounce that. I think it's ATOI. Sounds kind of silly. Anyways, right on. And I don't see any examples that says we have to take care of special cases, like if the number was negative or if the number is 0. So yeah, we're just going to use the ASCII charts to help us. So basically the output that we want. Oh, did it give any examples? No, it just says your task is to implement the function, and the function takes a string as an argument. So string as an argument, and converts it to an integer and returns it. And converts it to an integer and returns it. Okay, and converts to an int. And then we're going to return this output. So let's see. Oh, I know. Let's do 122. Let's choose a number or a string, and it's actually, let's make the string 1, 2, 3. So 123, and the input should be the string. Sorry, the string. Oh, that's gonna get confusing. Give me a second. Okay. So string, let's say, is 123, and int is 123, 123, or whatever it's called. Yes. And but if the string was something like 1, 2, a, then the int would be 0 or return 0 because a is not a valid integer. A is a character. So yeah, that's what it should do. And there's a trick to it because it's ASCII. We have to, essentially the trick is to convert it by the base 0, because ASCII 0 to 9 are real, like, proper values, or like representative values. So they, from 0 to 9, it really does convert to 0 to 9 in int. So these are representative. I don't know how to write representative, apparently. I'm just gonna put rep values. So yeah, so we're gonna, it would be easy to initialize everything as 0, of course, and then start with the first character and iterate through. I don't see any other better way. And basically for every character, update the answer with the number subtracted by 0, and then timing it by 10, and yeah. So then, because then we will be able to do numbers that are over 9, so like 10 and stuff, like double digit numbers. Okay, so let's see. Pretty easy. So yeah, we're gonna go and subtract. We're gonna subtract all the numbers by 0, number by 0, and then we are gonna take and then that'll give us the ASCII, and then we're gonna times it by 10. So times the number by 10. And then we're gonna return. So that's the trick. to converting ints properly, because like if you, oh my, I can't draw a line. Draw properly. Okay. Oh, I just remembered something I was supposed to do that I totally forgot to do. Oh my god, why is it always, ow. Why is it always in the worst times I think, oh, I forgot to do that. Okay, let me finish this up and I'll do the thing I forgot. Oh my goodness. I'm gonna define a toy with string as an argument, like the prompt says. No, there are no, so usually if there's a 0 or improper or whatever, but this is just a simple assuring that the input will be an integer. So we're just going to do that, and we're going to initialize the result to 0 like I mentioned before. We need a starting place to iterate through. So we're going to, now we have to write a typical for loop, a traditional for loop for I and the range. So we're going to take the index and the range into the length of the string or the length of the input. That's terrible handwriting. Then we're going to so I know how to get the ASCII code is OD ordinance or of this, and then we're going to get the string and string add I, which we're going to subtract by the ordinance of 0, which is actually 0 as I mentioned before. So that should take care of this guy. I think I'm missing this right here. I can't read my own writing, it's so messy. And then we're going to take the number. So currently is so currently it's, so this will make sense, but it will after we run through the first. We're going to take the result. I should probably do it on another line, but oh well, it's too late. I probably did in the wrong order. Okay, so yes, we are going to take the, oh, how am I going to fit all this in one line? Sorry, now the formatting will be a little messed up. But let's do, so R stands for result. Heck, I'm just going to change this to save myself space. R is result, R equals 0. Publish, okay. And then we're going to add this, and then we're going to obviously R times 10, and that's going to take care of this. And then we're going to return R here. Oh, that's N. That's R. Okay, and I'm going to turn R, and that's it. Pretty easy peasy. So basically, the I goes through, and it will take the result times it by 10, and this is 0. But then we have this, which is the first result, which is 1, because 1 minus 0 is 1, and then we're going to have return 1, and then we're going to iterate through again, and then 2 minus 0 is 2, and was I? Yeah, I think so. And then we have the result of 1 as the R now, because it's now 1, it's not 0 anymore, it's 1, and then 1 times 10 is 10, and then 10 times 2 is then 12. Oh my god, what the hell happened? It was going so terribly. Ugh, I don't, and anyways, 10, and then plus 2, and then it would be 12. And then we have one last thing on the thing, which is a 3, and then we're going to go 3. The ASCII of 3 minus the ASCII of 0 is 3, because 3 minus 0 is 3, and then we have 3. So now R is now 12, and then this is now 3, I think, 3, and then 12, And now that since this is 12, we're gonna times it by 10, and then times 10 by 10 is 120. Yeah, 120, and then 120 plus 3, and then you return R, and R is now 1, 2, 3, 123 like the original. So now it's an int instead of a string. So yeah. Okay, cool. Oh my god, I almost forgot. Um, so this is linear time, I think, because I see one for loop and one transversal only, and then you just do this for each transversal. So I'm pretty sure it's O of n time, and I don't think there's a way to optimize it that I've seen. So yeah, I mean, I guess I don't know if if the data gets really large, maybe there is, but yeah, um, and no, oh wait, that's my dog. Okay, give me a second. Give me a second. She wants to come in. Okay, what was I talking about? I'm back. Okay, yeah. So linear time because only one transversal is needed. Um, other things um like so I guess if statements, if it's like negative numbers or white space, and space complexity for this is constant, because I don't think we need to make anything for it. So yeah, that's it. Okay, cool. Bye bye. That's it. I don't remember. I think I'm done.